In this session, we are going to work with the collection API. Basically, when we talk about collection, what are the topics we are going to cover? Overview of collection API. What is system.collection namespace? Using array list or hash table. Using iComparer for sorting. IEnumerable and IEnumerator for iterating through items in the collection. This is our agenda for today. Now, what exactly is a collection? In all the sessions which we have covered so far, we have been dealing with only one object at a time. We never got a situation where we want to deal with multiple objects probably of the same time at the same time. For example, when we created account class, we created only one object of account class and we developed a GUI in which we put controls for testing only one object at a time. We never really bothered about situation where we would have more than one account object. What is that procedure to deal with that kind of situation? So this particular session, that is working with collections, is going to deal with situation where we want to have more than one object of similar type to be handled in a given project. Now, to start with a simple collection, I can also say array is a collection. Every array, whether it is integer array or double array or byte array or float array, all these are collections. Or it can be an array of computer, array of students, array of chair, array of faculty. It can be array of anything. Every array I treat as a collection. So what exactly is a collection? In simple words, collection is basically a combination of many objects coming together. That means instead of only one object, now we are talking about many objects in one object. So collection is an object used for managing many other objects so that it becomes easy to manage them. For example, when we put all the items in an array, obviously it becomes easy for iterating through all the items in the array. Visiting each and every item in the array becomes easier there. That doesn't happen when we want to deal with individual objects separately using their separate references. Imagine now a situation where I want to talk about 5 account objects. One of the options I have is I have 5 different variables: A1, A2, A3, A4, A5, and each of these objects refer to those corresponding, each of the reference would refer to the corresponding object. Now if I want to iterate through all the 5 of them, if I want to perform some common functionality on all 5 of them, can I use a for loop? What will I write in for loop? A1 is different from A2, A2 is different from A3. I can't use anything for writing common code. But same thing, if I put them in an array of account objects, I can use index and say A of 0, A of 1, A of 2, A of 3, A of 4. Like that I can visit in a for loop or probably a while loop all the items and perform some common logic on them. That is what is the basic benefit of dealing with collections. So array is one type of collection, stack is another type of collection, queue is a collection. Like that, there are so many other collection objects, collection types which are used in different type of situation. In .NET, to work with collection API, we have got a namespace called as system.collections. Everything falls under the namespace system.collection, and you see this is probably the partial list, not the complete list, but these are the list of all collection classes what we have, right? This is more extended. I have copied only this much, but yes, array list, bit array, different type of situation we are going to use different collection classes. And you also see here there are certain interfaces, not just collection classes. So now we are going to learn basically overview of few of these collection classes, how to use them with some sample program we are going to look at, what type of situation, which one to use we are going to look at, how they are related to each other we are going to look at, and proceed from there. Now look at this diagram. On top we have got IEnumerable, that's the parent of all collection API. This is an interface. As it starts with I, we can easily make out that this is an interface. This is also an interface. This is an interface. This is an interface. But array list and hash table are classes. So here can I say I list inherits I collection and I collection inherits IEnumerable. ArrayList implements IList, and thus can I say ArrayList implements iCollection and iEnumerable also? We have a rule, if you remember, if a class implements an interface, it must implement all the parent interfaces of that interface. So that's what is happening here. IList is implemented by ArrayList is implementing IList. Because ArrayList implements IList, it must implement iCollection and iEnumerable. Now what is the importance of iEnumerable, iCollection we see later. But now I would want to see what is the importance of iList and what is the importance of iDictionary. How are they different? In other words, I want to basically understand what is the difference between ArrayList collection and hash table collection. These are the two collection classes which are very commonly used in projects. Now ArrayList, I say, implements iList. Now what is ArrayList here? It's like an array, but the limitation of an array is, in array we do not have the facility of inserting item in between the collection. In array we don't have the facility of removing the item from in between. And rather arrays we can't even change the size, but ArrayList is more dynamic. ArrayList can grow as we want, it can grow. We can do easy insertions in ArrayList, and we can do easy deletions from ArrayList. It automatically manages itself. That's a beautiful advantage of ArrayList. So in what type of situation we are going to use ArrayList? Wherever we want to identify a collection of objects by their index position. I would say, let us say I want to find out in a group of let us say I have some 100 computers, and I want to find out which one I purchased first. So what I'll do is, as I purchase the computers, I get them from the database or whatsoever. Let's say as I got the computer, I identify every computer by its index position. I give them indexing. The index of the first item will be 0. The index of the second item will be 1. The index of the third item will be 2, and so on. So every item I give a index number. So later, whenever I want to find out an item by its index position, I can directly go to that item and pick it up. That's what is the basic advantage of ArrayList. So ArrayList is used in situation where we want to manage a collection of objects, items by their index position, identifying by their index position. Whereas hash table, which implements iDictionary and thus the parent interfaces, is useful in situation where we want to manage collection of objects. Each object is identified by a unique key. For example, I have, let us say, a collection of 100 students. I want to now identify a student by its roll number, so that I can directly go to a student with roll number so and so, rather than going to each and every student and checking whether their roll number is what I want or not. I don't want to iterate through them sequentially. I want to directly go to their position and pick it up. In those kind of situations, we are going to make use of hash table. I repeat, ArrayList is used in situation where ArrayList collection is used in situation where we want to retrieve items from the collection based on the index. Value is what? Item only. Whereas hash table is used in situation where I want to randomly pick up an item from the collection based on its key, which is supposed to be unique for every item. So let us now see how to use ArrayList and how to use hash table in programming. We'll take some small sample programs. We'll create a new project here. Let us say a C#. We can do with console based application itself. Let us call it as collections demo. Click on OK. We can actually get rid of all this, but now we need an interface. Sorry, we need a namespace that is using we need a namespace using system.collection. collections. This is the namespace we are in need of. Now I'll create an object of class ArrayList. Let us say AL demo is equal to new ArrayList. Now when we create an object of class ArrayList, we can here give something like capacity. Now what is this concept of capacity? Let's see that. Now I create an ArrayList. Now I'll try to print the capacity of ArrayList. Now what we will find is value we get is 0. That means there is no capacity assigned to the ArrayList. Now into ArrayList, let us add now some item. Now something important to note here is the item which we can add here, the value which we can add to the ArrayList is of type object. What does it mean? Because the data type here is object, we are